Hello, this lesson is about absolute value functions. So you've learned about what an absolute value is. Now we're going to talk about how they're related into a function. And so let's take a look at a few examples from the lesson to be able to give you an idea of what we do with these. So let's start with the first example. It says, what describes how to translate the graph y equals absolute value of x to obtain the graph of y equals the absolute value of x plus 7. Now, we've learned about transformations and looking at graphs and what they may do based on the changes to the actual equation or function. And so in this one, when we look at y equals absolute value of x, remember that's the parent or root function, depending on what math book you read. Some of them call it the parent function, some of them call it the root function. And so we know that it is going to be, if I were to graph it, a v looking function when it's graphed. And when we look at this, then we say, okay, well, let me go ahead and put so this is our graph here, and here's our x and our y axes. And so what happens is I don't have to make a table of values. If I understand my transformations, then I can know, if I know what the root function looks like, then I can know how to graph the new one. So in this case, we want the absolute value of x plus 7. And so based on our transformations, when I have a plus inside the function, so it's next to the x right here, then that's the plus or the minus, something in there is going to move it left or right. So it's going to either move it this way or this way. And so we have to remember what it is. This one is the weird one because since it's inside the function, we have to think of it backwards. So since it's a plus 7, it's actually going to move it to the left 7 spaces. So what happens is this one would get moved over, however many 7 is. We didn't quite make our graph to scale, but it would move it over 7 spaces. So when the question says, what describes how to translate the graph y equals absolute value of x to obtain the graph of y equals absolute value of x plus 7, all we would have to do is simply write down that it is going to be move 7 spaces to the left. Okay. And I put the graph here so you can see what's going on in the background, but to answer the question, we really just need to write. We don't have to graph anything. Okay. All right, let's take a look at another example of this. So the next one is, what is the equation of the new graph if y equals absolute value of x is translated so the point 1, 1 is moved to 1, 4. So we start with the point 1, 1 and we want to move it to 1, 4. Okay, so we have to think, again, based on the graph, what is happening here. So these points, remember, are x and y because we plot them on the graph. So when we look at this, if we want to move the point 1, 1 to 1, 4, what is actually moving? So I'm going to draw a graph here, hopefully a straight one. Let's try that again. Put in our tick marks so we can know what's going on. Here's our y-axis and our x-axis. Okay. And so let's take a look at these points. So we start with 1, 1. So that point is right here. and we want to move it to 1, 4. So now our new point is going to be 1, 4 up here. So what actually moved? Did the x point move or did the y point move? And when we look at it, the x is the same, right? They're both 1. The y actually moved. So what happened is, if I moved up, that means we had a vertical translation, which means that vertical translations are where we add or subtract something in the back. So for example, if we have some sort of function, we would have plus or minus some number at the end. Okay? Now these ones work the correct way. So if it's plus, we go up. If it's minus, we go down. Since we started at 1, 1 and we went to 1, 4, we went up. And so how many spaces did we go up? So this is the difference. It's not that we moved up 4, it's how many spaces are in between there. So if we look between these, how many spaces is there? 1, 2, 3 spaces. So what does our equation become? Our new equation becomes y equals the absolute value of x plus 3. All right. And one last example that we're going to do today. This one says to graph y equals negative absolute value of x plus 1. Okay, so remember, when all else fails, if I don't remember all of these great quick shortcuts to graph, I can always do an XY chart to graph. But in this case, let's take a look. So we want to graph this, so let's make sure we have a graph to do that on. Now remember, we can use our translations. So if we look at this in terms of translations, what's happening here? So we know that it's going to be a V shape, right? Because it's an absolute value, right? That's just the absolute value of x if we were to graph it. We have a plus 1 in there, but it's next to the x. So that means it's going to go left 1 space. And then we have this negative in the front of the function. So we have to remember, what does that mean? So if the negative is in front of the entire function, that means it has a reflection over the x-axis. Okay? So what does that mean? It's basically going to take our V and point it downward. So we know that the first point usually, if we're just graphing absolute value of x, starts at 0, 0. But in this case, I have to move it 1 space to the left. So now we're going to start right here. That's 1 space to the left. And then it reflects over the x-axis. So instead of pointing up, it's going to point down. And so our graph is going to look like this. And that's how we use those shortcuts to graph things pretty quickly. So now you have some examples from the lesson. You can use these examples to help you get through that lesson. And if you have any questions, please ask. Thanks.